Alright, today we're going to go over rational and irrational numbers, and hopefully during this lesson in the PowerPoint, we'll be able to classify numbers as either rational or irrational. A part of knowing rational or irrational numbers, you need to know certain like symbols of math, if you want to call it that, like pi and square root. Y'all are familiar with that? Okay, go to the next slide, please. I'm having technical difficulties. Okay, I'll give everybody the whiteboard. Take it like this. You just draw a line straight down the middle. And on one side put RA2. And on one side put IRR. Like that up there. Okay. Now we're going to go through. We're going to put each of these numbers under what you think it goes under. So 5, we believe is rational or irrational. So right on that side. Negative 3.5. What do you think?
Rational.
Put it on there. We'll see here in a second. Square root of 5. Your turn.
Rational.
Right, we'll see here in a second. And then you got 2 over 3, 2/3. So write it down. We'll see here in 1 second. Could you go on to the next one? Okay. These are examples of what rational numbers are. 3, -1, 2.5, 7 over 9, square root of 4. Pretty much for it to be a rational number, it cannot be repeating. Like the square root of 4, what is the square root of 4? Do y'all know?
2.
It'd be 2, which is just a real number. 2.5 does not repeat. -1 is just a real number with a negative. 3 is a real number. 7 over 9. Okay, let me get that one. Let me get this right here. Everybody good? Okay, could you go to the next one? These are examples of irrational numbers. This number right here. What is it? You know what the dots mean? Do y'all know what them? It means the number is repeating. It means it goes on forever. That will be an irrational number because it never ends. Most square roots, unless it'll go straight down to a real number, like square root of 4, they will be irrational. Because if you put that in a calculator, you get a number with a big old long decimal that keeps on going. Pi is 3.14, and then a bunch of numbers after that. So that one's irrational as well. What does all this have in common? Do y'all know? Well, 3 of them got that square root. But if you take the square root down, what would it be? Would they all look similar to this? Could you go to the next one? This is like the definition of rational and irrational. Rational numbers are numbers that can be written as ratios, and irrational numbers are numbers that cannot. Like a ratio would be writing it like 2 to 2 or 4 to 2 or something like that is like a ratio. Okay, so I want y'all to give me a number, and then we're gonna decide if it goes rational or irrational together before we do these next two. So you just say a number. 4. What do y'all think 4 goes under? What number you got?
9.
9?
4.5.
4.5? 6. Okay. So where would we put 9? Rational? You say 9.5 or 4.5? 4.5. Where would we put that? Huh? Rational? Look, like, if it's just 4.5, just straight up 4.5, no repeating, no long decimals, what do you think it go under? Rational, yeah, that's right. And then you said 6. Where would we put 6? Yeah, the 6 is just a plain real number. All these are just plain real numbers, except the one with a decimal, but it don't repeat. So every number right there would be rational. What's an example of irrational? Yeah. So like, we could do like square root of, like what, 15? Just numbers like that usually are rational. What was one that was irrational? What was it? Square root of 4. It went straight down the 2 if you put it in a calculator. That's what made it rational, because it became a real number. Okay, now after this, let me pick these up real quick. Okay, we're done with it. Okay. Now before we do these, or we go through the rest of this PowerPoint, it'll be, you can clear them off without erasing. Just leave the columns and stuff for rewriting if you have to. Just write it the same way, down the middle, rational, irrational. You go to the next one. So we're gonna decide together whether this whatever number it shows, we're gonna put it under rational or irrational. So that just array with 5. Put it under what we think it goes under. Okay. -2. Alright. Square root of 8. Okay.
So now, can you scoot over, I can't see that,
Yeah.
can't see it, sorry, for some reason it. So go on,
Yeah, we're good, I think. Square root of 16. Okay. Square root of 2. Alright. 1/3. Alright. 5/9. 5/9. Alright. 5.81. Okay. Now we got a big old long repeating decimal. Okay. I think when you click it, put it in, what column it goes under. I think that's how that one works. Yeah, okay, I thought so. Okay, so we see where all the numbers go. Like square root of 6, it goes to irrational. That's just a plain, just old-fashioned decimal. They don't have no repeating, so it's rational. 3.14, that's what pi is. But if it ain't in the symbol pi, it's just the numbers, it would be rational because it ends after 4, and it don't carry on forever. Then the 2 square roots, if you put them in a calculator, you get a big old long decimal. That's why those are irrational. Alright. Okay, so now we got this one. Quiz them. Y'all go ahead and erase all that stuff off. I think everybody's done. I'll take these. Now I believe we're done. Okay. Thank you.